When people say the Gulf Stream is collapsing, they usually mean something else. The real scientific concern is not the Gulf Stream by itself, but the AMOC, the Atlantic Meridional Overturning Circulation. That distinction matters because it changes what the risk is, what the evidence shows, and what Europe should actually worry about. The Gulf Stream is a mainly wind-driven surface current flowing along the east coast of the United States before turning out into the Atlantic. The AMOC is much bigger and more complex. It includes warm surface waters moving northward, the formation of cold, salty, dense water at high latitudes, deep southward return flow, and constant interaction between temperature, salinity, sea ice, the atmosphere, and the ocean. It is not a simple conveyor belt with one on-off switch. So the question is not whether the Gulf Stream will suddenly reverse and plunge Europe into instant deep freeze. That is not the mainstream scientific expectation. The bigger concern is whether the AMOC weakens further and what that would mean for the climate system around the Atlantic. On current knowledge, a substantial weakening of the AMOC over this century is very likely. A full collapse before 2100 is considered unlikely, although not impossible. That is the balance of evidence. Not business as usual, but not a certain catastrophe either. To understand why this matters, start with how the overturning works. In the high-latitude North Atlantic and Nordic seas, surface waters can become cold and salty enough to grow dense and sink. That sinking helps drive deep southward flow, while surface waters move in to replace what has gone down. If the surface water becomes fresher, from more rainfall, more river input, or meltwater from Greenland, it becomes lighter and less willing to sink. Reduced sinking can weaken the overturning circulation. That mechanism is one reason climate scientists are watching the North Atlantic so closely. A warmer world tends to intensify parts of the water cycle and add fresh water to key regions. The direction of risk is clearer than the exact outcome. Science supports the direction of change more strongly than its timing or endpoint. In other words, further weakening is very likely, but its magnitude, pace, and whether it reaches a tipping point are not known precisely. There is another common misunderstanding here. Europe's relatively mild climate is not caused solely by the Gulf Stream. Westerly winds, the nearby ocean, the Atlantic's huge heat storage, atmospheric circulation, and ocean heat transport all help. So if the AMOC weakens, Europe does not automatically enter a new ice age. Global warming remains the dominant trend. That said, a weaker AMOC could still matter a great deal. Its effects would likely be gradual, regionally uneven, and felt most strongly around the North Atlantic, especially in winter. It could alter heat distribution, rainfall patterns, marine habitats, ecosystems, agriculture, coastal protection, and energy demand. It could also affect sea level, including additional rise along the U.S. East Coast. So this is not a movie-style flip into frozen chaos. It is a slower, more uneven reshaping of regional climate risks. How do we know whether the AMOC is already changing? That is where the evidence becomes more complicated than headlines suggest. Continuous direct monitoring of the AMOC only began in 2004, with the rapid array at about 26.5 degrees north. Later observing systems expanded coverage, but this still means the direct record is short. It shows large year-to-year and multi-year variability. The AMOC naturally wobbles. Because of that, a few weak years are not evidence of collapse, and short-term dips cannot be treated as historic turning points. Before 2004, scientists had to infer AMOC behavior from much less complete information: ship measurements, isolated observations, satellites, and climate reconstructions. To go back further still, they rely on indirect evidence, or proxies, such as sediment cores, seafloor grain sizes, chemical signatures, corals, ice cores, and patterns of sea surface temperature. These proxies are not perfect. None is a magical readout of overturning strength. But when several independent lines point in a similar direction, they become more persuasive. Taken together, direct observations, multiple analyses, and proxy evidence suggest the AMOC has probably weakened relative to pre-industrial conditions. Probably is the right word here. It reflects meaningful evidence, but also the limits of measurement and reconstruction. One famous clue is the so-called cold blob in the subpolar North Atlantic, south of Greenland. This patch of relative coolness broadly fits the idea of weaker northward heat transport, but it is not courtroom-proof evidence of imminent collapse. Other factors could also contribute, including atmospheric circulation, aerosols, natural variability, ocean dynamics, and mixing. It is a signal worth taking seriously, not a final verdict. This is also where the scientific debate sharpens. Some studies, especially those using statistical early warning indicators or simplified dynamical models, suggest the AMOC may be approaching a tipping point. They point to signs such as increased sluggishness, stronger variability, or slower recovery after disturbances. In plain language, the system may be becoming less resilient. Those studies should not be dismissed. Earth's climate history does show that abrupt circulation-linked changes are possible. The past proves the climate system can shift sharply under the right conditions. But history does not prove that such a shift is imminent now. And many advanced climate models, observational analyses, and major scientific institutions judge significant weakening to be likely while an imminent full collapse remains less likely. The evidence for a near-term breakdown is not strong enough to support the most dramatic claims. So this is not a 50-50 split between nothing to see here and collapse is just around the corner. The strongest consensus sits between alarm and dismissal. The AMOC has probably weakened already. Further weakening this century is very likely. The exact timing, the magnitude, and whether a tipping point is crossed remain uncertain. What would that mean for Europe specifically? The most plausible baseline is moderate weakening. In that future, Europe still warms overall because of greenhouse gases, but some regions, especially around the North Atlantic, could warm less than they otherwise would. Winters in some areas could shift, rainfall patterns could change, marine ecosystems and fisheries could be disrupted. Agriculture, infrastructure planning, and energy demand would all have to adapt to more complex regional conditions. A second future is strong weakening. In that case, regional cooling relative to the background warming could become more pronounced around parts of the North Atlantic. Tropical rain belts could shift. Weather patterns might change more substantially. Coastal impacts could intensify, including added sea level rise along the U.S. East Coast. The disruptions to ecosystems and economies would be larger and harder to manage. The third future is abrupt collapse. This is the most dramatic scenario, but not the most likely this century on current evidence. If it happened, the consequences would be severe and far-reaching. But responsible narration has to preserve the scientific weighting. Possible, serious, but unlikely before 2100 based on what we know now. That weighting matters because public understanding often swings between two bad extremes. One is panic. The idea that Europe is about to freeze overnight because the Gulf Stream will stop next year. The other is complacency. The idea that if collapse is unlikely this century, then the whole issue can be ignored. Neither view matches the evidence. A final correction is worth making because strange explanations often appear around this topic. There is no robust mechanism linking geomagnetic pole shifts to AMOC collapse. That idea does not have solid support in this context. The more grounded picture is harder to turn into a slogan, but closer to reality. The AMOC is a complex overturning system, not just the Gulf Stream. It has probably weakened already. Further weakening under continued warming is very likely. The consequences would likely be gradual, uneven, and important, especially around the North Atlantic. A continent-wide new ice age is not the expected outcome, and global warming remains the dominant trend. At the same time, science cannot yet pin down the exact pace, scale, or whether a tipping point will be crossed. So is Europe facing a sudden cold shock? On present evidence, probably not in the dramatic way popular culture imagines. But is Europe and the wider Atlantic world facing a real climate risk from a weakening AMOC? Yes, very likely. The right stance is neither panic nor indifference. It is alert realism, taking the warning seriously, respecting the uncertainty, and paying close attention to how observation, models, and the real ocean continue to evolve. Subscribe, enable notifications, and tell us in the comments which topic Aurora knowledge should explore next.